Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problem number 6 of the 2014 AP Calculus AB released exams. And this problem focuses on differential equations. Alright, so problem 6 is as follows. Consider the differential equation dy dx equals quantity 3 minus y cosine x. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. Part A. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So this question is pretty straightforward. What you're expected to do here is follow the general pattern of the slope field to generate the solution curve. Your solution curve has to go through the point 0, 1. So first step is to graph the point 0, 1 on this coordinate system. Since that's 3, this is 1 on the y. And this point also corresponds to 0 on the x. Okay, so this is the point that we're looking at right here. So what does the solution curve through the point 0, 1 look like? So there are many ways you can draw the solution, but the general pattern of the solution curve has to look the same. Okay, so I'm going to start off using dots. So following the pattern of this slope field, if you look at all the lines here, they have a positive slope going up, so it goes up, following that general pattern. And then remember, these lines in the slope field are a snapshot of the tangent line to this solution curve at the point of tangency. Okay, so these are the points that formulate the solution curve to the right of the y-axis. Now to the left of the x-axis, we're basically going to follow the same pattern. We're going to descend down, following the pattern of the slope field. And then you notice we curve around, just following the general pattern of the slope field. And then we just take off. Okay, so this is basically what it looks like. So let's make it solid. Have a line going like that. And then like that. All right. And then the other direction, it goes down. My line is kind of crooked, but that's fine. Makes that curve. And then it goes up like that. All right, so this is what the general, the solution curve that goes through the point 0, 1 should look like. Okay, so your graph might not look exactly like this, but it should follow this general pattern in order for you to get full credit for this problem. All right, so for part B, we have to write an equation for the tangent line to the solution curve in part A at the point 0, 1. And then use the equation to approximate f of 0.2. Okay? All right, so whenever you see any question asking about tangent lines and approximations with your tangent line, immediately think point-slope form of the equation of the line, basic algebra 1. Okay? So the formula that we're going to be using is y minus y1 equals mx minus x1, where m is the derivative, right? So that's the formula we're going to be using. So in order for us to write the equation of the tangent line, we need 3 components. We need y1, x1, and the slope. All right? So we're given the points that we've provided is 0, 1. Okay, so x1, y1, is 0, 1. All right, so in our formula for x1, we're going to be putting in 0. For y1, we're going to be putting in 1. That's the easy part. Now the hard part, what is the slope at 0, 1? The slope at 0, 1 is simply the derivative at 0, 1. But what do we know dy dx as being in this problem? We have provided the differential equation, which is dy dx equals, let's write that down, dy dx equals quantity 3 minus y cosine x. So how do we find m? simply evaluate this differential equation at x equals 0 and y equals 1. That would give us a slope, okay? So the y dx evaluated at 0, 1 is simply 3 minus, instead of y, we put in 1 for y, cosine 0, because x is 0. Okay, cosine 0. Okay, let's evaluate this expression. 3 minus 1 is 2. Cosine 0, what is cosine 0? If you use your unit circle, the x-coordinate of the point at the 0 degree for the positive x is, let's see, is 1. Or you can use the cosine curve. I like to use the cosine curve. So if you use your cosine curve, that's 1 period right there. Cosine 0 is 1. All right? So cosine 0 is 1. We substitute that here. And now we have our slope. Our slope is 2. Okay? All right, so how do we proceed? We know what the slope is now. M is equal to 2. We know x1 is 0. Let's just put it over here for easy reference. x1 is 0, y1 is 1. So the equation of our line is going to be y minus y1 equals m times x minus x1. Okay, and if we put this in slope-intercept form, y minus 1 distributed 2 equals 2x, add 1 to both sides. We have the equation of the line y is equal to 2x plus 1. All right, so that is the equation of your tangent line. Okay, so let's also label this as the equation for the tangent line, is y equals 2x plus 1. So you basically get 1 point for this part, okay? Remember, there are 2 parts to this question. Do not forget that. You are to use the equation to approximate f of 0.2. So how do you do that? So to approximate f of 0.2, you simply evaluate your tangent line at this input value. So f of 0.2, don't let that confuse you, is the same thing as y evaluated at 0.2. Okay, so what is y evaluated as 0.2? Remember, y equals to x plus 1 is the same thing as writing y of x equals 2x plus 1, since x is the independent variable. So y of 0.2 is what? Is 2 times 0.2 plus 1. How did we get this? We simply inputted 0.2 into this tangent line function that we came up with. All right, so evaluate this. We have 2 times 0.2 is 0.4 plus 1, and final answer is 1.4. So that's the approximation of the value of this function at f of 0.2 using your tangent line. All right, part C, we have to find y equals f of x, the particular solution to the differential equation with the initial condition f of 0 equals 1. Customarily, whenever you're asked to solve a differential equation in an AP free response question, those questions normally carry the highest amount of points, normally 6 to 7 points if the domain question is included. Okay, so it's important for you to know how to solve differential equations, because you can score a lot of points just by knowing how to do it. Parts A and B were a total of 3 points. 2 points for question 2 for question B, and 1 point for part A. But question C has 6 points, which is a lot of points. All right, so let's go ahead and write down the differential equation. We have dy dx equals 3 minus y cosine x. So all the differential equation problems that require solving anomaly separation of variables type problems. Okay, so that's the method we're going to use here, the method of separation of variables. So to separate the variables, we simply want all the y's on the left side of the equal sign and all the x's on the right side. To accomplish that, let's move the x's first by multiplying both sides by the x. And we have dy equals 3 minus y cosine x dx. Now, we need this quantity 3 minus y grouped together, move to the left side so we can have our variables separated. So we simply divide both sides of our equation by 3 minus y, 3 minus y. On the left side, I'm going to rewrite this as an integral of 1 over 3 minus y dy equals, on the right side, 3 minus y and 3 minus y divide out. So we have cosine x. Okay, this integral symbol doesn't go there, sorry. Okay, and then we have cosine x dx. Okay, so what we've accomplished so far is separating the variables. If you execute this step correctly to this point, you earn 1 point. Okay, now next thing we're going to do is we're going to integrate both sides of the equation so that we can get rid of this dy and the dx's, the differentials. So we'll basically integrate the left and the right side. Now just a real quick review, remember that the integral of 1 over mx plus b, the x is the natural logarithm of the inner function, that linear function mx plus b, divided by the coefficient of x, which is m, plus your constant c. And also if you integrate cosine x dx, you get sine x plus c. Remember, when you differentiate sine, the sign doesn't change. So when you integrate cosine, you shouldn't expect the sign to change either. All right? So we're going to apply this differentiation rule here. So I'm going to rewrite the left side so that it's in my plus v format. So we have the integral of 1 over negative y plus 3 dy equals the integral of cosine x dx. So let's go ahead and integrate. The left side, if we integrate that, we have the natural logarithm of the absolute value of negative y plus 3 divided by negative 1. Don't forget that, okay? Because you have a negative 1 as the m here, equals the integral of cosine x is sine x. And don't forget our plus c. This c is a composite c, a combination of the c from the left and the right side. Okay, now let's go ahead and simplify a little bit further. We can move this minus up here, so we have negative, the natural logarithm of the absolute value of negative y plus 3 equals sine x plus c. Okay, so if you integrate correctly and you add the c constant of integration, you get 3 points, okay? Which is looking good. You're adding up your points. So adding that plus c, and integrating correctly, you end up with 3 points. Now, when you have this situation right here, this is a good point to find the c value, okay? So let's go ahead and find c. If you want to find c, we're going to make use of the initial conditions. So we want to recall that we have an initial condition. F of 0 is equal to 1. What on earth does this mean? How does this help us? The input, or your independent variable, is x, and your output is y. So we simply plug in x and y into this equation and solve for c, okay? So to find c, we're just going to do the following. We are going to compute the negative natural logarithm of negative 1 plus 3 equals sine of 0 plus c. All right, let's simplify this. We have negative natural logarithm of the absolute value of 2 equals sine of 0. If you draw your sine curve, have that s starting from the center, sine of 0 is 0 plus c. Okay, and then we clearly see that c is negative natural logarithm of the absolute value of 2. All right, so solving all the way to here, we have 1 point for the antiderivative, actually 2 points for the anti-differentiation, finding the antiderivative correctly, and then another 1 point for finding the c constant of integration by using the initial condition. So having plus c, we have a 1, and then using the initial condition, we have another 1 point. So far we have a total of 5 points. Now the last part is just simply solving for y after plugging in your c value into this equation right here. Okay, so the goal now is to solve for y. Okay, all right, let's go ahead and do that. We have negative natural logarithm of the absolute value of negative y plus 3 equals sine of x plus c. Okay, but we can just put negative ln of the absolute value of 2. But we know what the absolute value of 2 is. The absolute value of 2 is simply 2. Okay, so we don't need to carry that absolute value with us. All right, now we have a minus here. We can divide both sides of our equation by negative 1, or multiply by negative 1 is the same thing. So divide everything by negative 1. That leaves us with the natural logarithm of the absolute value of negative y plus 3 equals negative sine x plus ln 2. Okay, now we have to undo this ln. The inverse of your natural logarithm function is the exponential function e. So you exponentiate both sides of your equation using e as the base. So e to the ln of absolute value of negative y plus 3 is equal to e to the negative sine x plus ln 2. Okay, now on the left side we have this inverse interaction happening here. E and ln cancel out, so we have the absolute value of negative y plus 3 equals e parenthesis negative sine x plus ln 2. Okay, now there's some really neat tricks we can do with the properties of exponents on the right side to help us simplify this expression, and then we'll also look at what's going on the left side also. Okay, so on the left side we have plus or minus negative y plus 3, and then on the right side we have, now you're adding exponents. What do you do with the basis of an exponent in order for you to add the powers? You add the powers anytime you're multiplying. Okay, so let's express this exponent as a product of the two exponents that results in this expression right here. So since we're adding, it is simply e to the negative sine x times e to the ln 2. Now how on earth did that happen? Take a look at this rule here. What is a to the x times a to the y? Whenever you're multiplying exponents of the same base, you add the powers. So we're just going backwards here. We're going from the combined form into the factors form. Okay? All right. Now let's shift our attention back to the left side here. Since we have the initial condition was that f of 0 is equal to 1. So y of 0 is equal to 1. What does that tell us about the sign? Now one easy trick to figure this out, just simply look at y. What is the sign of y here? Y is positive, right? So since y is positive, guess what? We're going to take the positive component of this sign. So we're going to have positive negative y plus 3 equals e to the negative sine x. Now what happens here? Remember, e and ln are inverse operations. So using the inverse property of exponents, e to the ln 2 is simply 2. Okay, because this e and the ln cancels out as it happened up here. All right, so to finish this off, let's just rewrite this right side and move 3 over and also get rid of this negative 1. All right, so if you subtract 3 from both sides, we have negative y equals 2e to the negative sine x, and then minus 3. And don't forget we have this minus here. So to address that negativity, we divide every single term by negative 1. And our final particular solution is y equals negative 2e to the negative sine x plus 3. And there goes your particular solution for the differential equation. Okay? Now, one thing I want you to note is that all this work we did solving for y from here all the way down to the end, guess how many points we earned there? Just 1 point. Being able to solve for y, all this weird looking algebra that we just did, just earns us just 1 point. Okay? So if we're able to successfully anti-differentiate and include the c value here, and then we're able to find out what c is, we've earned 5 out of the 6 points in this question. Okay, so you can see how beneficial it is for you to master this algorithm out, especially up to the point where you can find c. In that case, you've earned almost all the points. Okay? Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We appreciate the positive feedback. If you have any questions about this problem or any differential equation question in general, just place your question in the comment section below, and we'll be glad to address it as soon as possible. Do not forget to subscribe to our channel for updates to other great tutorials such as this. More clips can be found on math.serve.com under AP Calculus. Thanks again for watching, and have a wonderful day.